A floppy drive is a magnetic storage device that is used to read and store data using a floppy disk. A floppy disk is a data storage medium that is made up of a thin magnetic disk enclosed in plastic. And this disk is where data is stored to, and it enables information to be transferred from one computer to another. When computers first came out, this was how data was transferred between computers. But floppy disks and drives are slowly dying out because of their small storage capacities and have almost become obsolete because of the invention of networking and larger storage mediums such as CD and DVD-ROMs. A computer has basically two different types of memory, primary memory and secondary memory. Primary memory is temporary, which we'll talk about later. Secondary memory is permanent, and this deals with the hard disk drive. The hard disk drive is a sealed case that contains disks, and these disks is where the actual data is stored on. These disks rotate at high speeds, and as they do, the actuator arm will either write data to the disks or read data from the disks, depending upon what the user wants to do. And hard drives are considered non-volatile because they can retain and store data even when the power is turned off. There are three different types of hard drives. The first type is called Parallel ATA, also known as eIDE. Now this is an older standard hard drive that uses a 40-pin ribbon cable as its connector. The cable has a connection on each end and one in the middle, which enables the cable to support two devices, such as two hard drives, two CD-ROM drives, or a combination of one of each. The hard drive that is connected to the end of the cable would be considered the master drive, and the hard drive that is attached to the middle connector would be considered the slave drive. Older motherboards had two PATA connection interfaces, so it can support up to 4 drives total. The latest standard on these drives is called ATA 133, which has a data transfer speed of 133 megabytes per second. But PATA drives are a dying breed and have largely been replaced by the faster speeds of SATA. Another type of hard drive is called Serial ATA. Now this is a newer standard that is faster than PATA. Instead of data traveling in a parallel path, the data travels in a serial path, which means that data travels one bit at a time. SATA drives have fast transfer speeds up to 6 gigabits per second, which is considerably faster. Other advantages that SATA has over PATA is that the drives are hot swappable and the cables are smaller, which makes cable management a lot easier. And the latest standard of hard drives is solid state. Now these drives have no moving parts. This type of drive uses memory chips to store data. And since it has no moving parts, the data transfer is very fast. Removable storage is both convenient and portable because these types of storage are not stored internally in a computer. They are attached from the outside. For example, a tape drive. A tape drive is an inexpensive way to back up data from your hard drive. It attaches to a computer, usually with a USB cable, and data is backed up sequentially to tape, which means that if you ever have to restore the data, you have to restore the data in the same order as you backed it up. CD-ROM drives have become a standard component in computers today. It's a device that reads data from a CD-ROM which is a disk that stores permanent data. CD-ROM stands for Compact Disk Read-Only Memory, which means that the data can only be read and cannot be changed or written to. CDRW stands for Compact Disk Rewritable. A CDRW drive can change or write data to a CD. It has a moving laser assembly that writes or burns the data onto the CD. There are two different kinds of CDs that can be written to: a CDR, which stands for CD recordable, or a CDRW, which stands for CD rewritable. CDRs can only be written once too, but a CDRW allows data to be rewritten multiple times. And CD-ROMs hold approximately 700 megs of data. A DVD-ROM drive is a device that reads DVD discs. The DVD drive has largely replaced ordinary CD-ROM drives because of the larger storage capacity of DVD discs. A DVD can store approximately 4.7 gigabytes of data. And all DVD drives today can read both DVD and CD-ROMs. And like a CD-RW drive, there is also a DVD-RW drive. And this can change or write data onto a DVD. It can write data onto DVD-R discs and rewrite data onto DVD-RW discs. And as stated previously, a DVD disc can hold approximately 4.7 gigs of data. And some DVD burners have the capability of burning dual-layer DVDs. And these are called dual-layer DVD-RW drives. Dual-layer DVDs have two recordable layers, so they can store nearly twice the amount of data than a regular DVD. Dual-layer DVDs can hold approximately 8.5 gigs of data. Blu-ray is the latest optical drive to date that was released in 2006. Blu-ray will eventually replace the DVD format because of its high capacity. Blu-ray uses a shorter wavelength laser compared to DVD, which allows a Blu-ray disc to store far more data than a DVD. A standard Blu-ray disc can hold 25 gigabytes of data, which is 5 times more than a DVD. Secure digital or SD cards are a popular type of flash memory. These are primarily used in digital cameras for storing photographs and videos. These photographs and videos can then be easily transferred to a computer that has an SD card reader interface. And SD cards come in various capacities, anywhere from 2 gigabytes to 64 gigabytes. Another type of removable storage is what's known as a solid-state disk. Now these have no movable parts. This type of memory uses memory chips to store data. These include thumb drives. A thumb drive is a miniature storage device with a USB interface. These devices can store anywhere from 256 megs to 64 gigabytes, and their size is small enough to fit on a keychain. They are a fast and convenient way to store data on the go. Other types of removable storage are external hard drives. An external hard drive is a hard drive that's enclosed in a case. It's a portable hard drive that can be externally attached to any computer, typically using a USB or FireWire interface. External hard drives are primarily used to back up data from a computer's hard drive for safe keeping. And finally, there are external CDRW drives. This is a portable CD burner that can be externally attached to a computer for purposes of burning data to a CD. It also attaches to a computer, typically using a USB or FireWire interface. The power supply is the device that supplies power to the computer. It's a square metal box with a bunch of wires emerging from one end. It fits inside the computer case and is usually located at the very top or the bottom of a standard tower case. The power supply converts 110-volt AC current into the specific voltages that the computer needs. The most common form factor that a power supply comes in is ATX. The power supply is equipped with different types of connectors. One connector is called the P1 connector. This is the main power connector that connects directly into the motherboard and provides it with power. The P1 connector has either 20 or 24 pins. Another type of connector is called the P4. This is a 4-pin connector that also connects into the motherboard, and its purpose is to supply power to the CPU. This connector is used with modern motherboards. Another connector is called Molex. The Molex connector is a 4-pin connector that connects disk drives such as hard drives and CD and DVD-ROM drives. There is also a serial ATA connector. This is a 15-pin connector, and this is used to connect disk drives that have a serial ATA power plug. Another connector is called the 4-pin Berg connector, or mini connector. This is a small connector that is used to supply power to the floppy drive. And finally, there is the 6-pin connector, and this is used to supply power to certain PCIe video cards. The motherboard is the main component of a computer. It's basically a large circuit board where all the computer components connect to, such as the processor socket. The processor socket is where the CPU, or Central Processing Unit, is placed. There's also the memory slots, and this is where the primary memory modules, known as RAM, are inserted. And there's also the bus slots. The bus slots are used to install various components to add more capabilities to a computer, such as a video card, sound card, network card, and so on. Motherboards come in different shapes and sizes, known as a form factor. The most common form factor motherboard that is used in PCs today is ATX. ATX stands for Advanced Technology Extended. It was created in 1995 by Intel and is now the de facto standard form factor for PCs today. A full-size ATX motherboard is 12 inches by 9.6 inches. Prior to the development of ATX was the AT form factor. AT stands for Advanced Technology. This was the form factor that was used in the 1980s that was developed by IBM. AT motherboards are 12 inches by 13.8 inches in size, and they are no longer in development since the succession of ATX. Another version of the ATX motherboard is the Micro ATX. Micro ATX motherboards are smaller than ATX boards, as its name suggests. Micro ATX boards are 9.6 inches by 9.6 inches, so it's a square design compared to the standard rectangular design of the ATX. They are cheaper than ATX boards and were designed to fit in smaller computer cases. They also have fewer features and consume less power than a standard ATX board. The BTX form factor was designed by Intel to make further improvements from the ATX form factor, such as an improved board design, which creates a more inline airflow, which improves cooling. For example, notice how the memory and bus slots are horizontal, flowing with the direction of the airflow instead of inhibiting compared to the ATX form factor. Another improvement is the structure design, which is flexible enough to work in both smaller cases and larger tower cases. And BTX motherboards take full advantage of the new input-output technologies such as serial ATA, USB 2.0, and PCI Express. Even smaller than the micro ATX and BTX motherboards, there's the ITX form factor. The ITX form factor came out in 2001, starting with the mini ITX shown here. And this was designed for the ever-increasing demand for smaller space-saving computers. The ITX standard consumes less power, and because they use less power, they are often cooled only by the use of heat sinks, and not with fans. ITX was developed by VIA Technologies, and there are currently 4 sizes that are in the ITX form factor. There's the Mini ITX, there's also the Nano ITX, which came out in 2005 and was designed to be used in devices such as digital video recorders, media centers, and cars. Then there's also the Pico ITX, which came out in 2007, and in 2009, VIA Technologies introduced the smallest x86 CPU module specification in the industry with the release of the Mobile ITX. The Mobile ITX measures 6 centimeters by 6 centimeters, and it was designed to provide developers with a standardized and ultra-compact specification for building new computer-based products. Another form factor is the NLX. NLX was created by Intel, and it was designed for low-end, low-profile computers. Instead of expansion cards that plug perpendicular into the motherboard, the NLX boards use a riser card, where expansion cards can plug in parallel with the motherboard. You would typically find NLX boards in slimline computer cases. Motherboards come built with several input-output interfaces. These interfaces are largely located on the rear input-output panel of the motherboard. For example, the PS2 connector. The PS2 connector is a 6-pin multi-DIN connector. A motherboard will typically have 2 of these and are usually located towards the top of the motherboard. One connector is for plugging in the mouse. This is the green PS2 slot. And the other is for plugging in the keyboard, which is the purple slot. But PS2 connectors are an older technology and is slowly being phased out in favor of the USB port. The most common interface on a motherboard is the USB port. USB stands for Universal Serial Bus, and motherboards will typically have several USB ports because there are so many different peripherals that utilize the USB interface, such as keyboards, mice, cameras, external drives, and printers. In addition to connectivity, the USB port also supplies electric power to that specific peripheral. Some USB ports are mounted on the rear input-output panel, and some are located directly on the surface of the motherboard. The first USB interface was version 1.0 in 1996. The transfer speed was 1.5 megabits per second. Version 1.1 was introduced in 1998 with a transfer speed of 12 megabits per second. Version 2.0 came out in 2001 with a transfer speed of 480 megabits per second. And the latest version is USB 3.0. This has data transfer speeds of up to 5 gigabits per second. Another interface that can be found in older motherboards is the serial port. The term serial refers to sending data one bit at a time. The serial port is an older technology interface which is rarely seen on new motherboards today. Back then, this was mainly used for connecting terminals and modems to computers. But now it has been widely replaced by the faster USB interface. The most common interface of a serial port is the RS-232 standard, which uses the common D connector, such as the DE9. The parallel port is another interface that could be found on a motherboard I/O panel. It was mainly used for connecting printers. And like the serial port, it is also being phased out and replaced by the faster performance of a USB port. It uses a wide D-sub connector known as the DB25. And unlike serial ports that send data one bit at a time, the parallel port sends data signals simultaneously over several parallel channels. A video adapter is another interface that could appear on the motherboard. Now I say it could appear because some motherboards have a video adapter and some don't. But the motherboards that do have a video adapter, then this is known as integrated video, because the video adapter and the motherboard are essentially one unit. The video adapter is what generates images from your computer to your monitor. The most common kind of port on an integrated video adapter is VGA, which stands for Video Graphics Array. The VGA port carries analog data. It has 15 pins divided into 3 rows and usually has a blue color. Integrated video adapters are usually not very powerful. They are good for normal everyday use with light applications, but when used for extensive graphic applications, such as gaming, they can fall short. That's why a lot of people will bypass the integrated video and buy an aftermarket video card that has enough power to suit their needs. The IEEE 1394 connector is commonly known as FireWire. FireWire is recognized by its D shape and is commonly used to attach devices such as digital cameras and printers. It's very similar to a USB port. FireWire and USB are both used to attach peripherals, and they both have similar transfer speeds. But FireWire is not as popular as USB. That's why on a modern motherboard today, there might not be any FireWire ports. Or if there are, you might find 1 or 2. And FireWire has a transfer speed of 400 megabits per second. The NIC or Network Interface Card is a port on the motherboard that is used for networking purposes, such as connecting to the internet and sharing data between computers. The port is designed for an Ethernet cable with an attached RJ45 connector. A NIC provides a computer with a constant dedicated connection to a network. And each NIC has its own unique identifier called a MAC address. The transfer speed ranges from 10 to 1,000 megabits per second. A sound card is another type of interface that could be found on a motherboard. And just like integrated video, if a motherboard has a sound card built in, then this is known as integrated sound. A sound card is what processes audio through the computer's speakers. A basic sound card has an audio output port for attaching speakers and an input port for a microphone for recording purposes. More sophisticated sound cards will have extra ports. For example, ports for subwoofers and surround sound, and ports for other digital audio equipment. Some motherboards have a SATA port on the rear input-output panel. This is known as eSATA or external SATA. eSATA is for attaching an external SATA drive to a computer. For example, an external SATA hard drive. It functions similar to USB and FireWire, but the transfer speed is faster. But the disadvantage it has compared to USB and FireWire is that eSATA requires a separate power plug to supply the drive with power. But there is a new SATA port called eSATA P, which is power over eSATA. This port combines data transfer and power in an all-in-one port, similar to USB and FireWire. Adapter cards or expansion cards are circuit boards that can be installed into the expansion slots on a computer's motherboard. These adapter cards are installed to increase the functionality of the computer. Some examples of expansion cards are video cards, audio cards, storage cards, and so on. One of the most common adapter cards is a video card. A video card is what generates images from your computer to your monitor. A typical video card is a printed circuit board that directly attaches to the computer's motherboard. Video cards are also known as graphics cards, graphics adapters, and so on. A video card has several key components, such as a graphics processor unit or GPU, memory chips, a bus type, and video ports. The way video is transferred from the video card to the monitor is through the video ports. There are several different types of video ports that are used today. One port is called S-video or separate video, or also known as super video. S-video is an analog transmitter. It transmits two signals over one cable. One signal is for color, and the other signal is for brightness. The S-video port is round and is usually a black color. Another port is called VGA. This stands for Video Graphics Array. The VGA port is an older technology that was developed in 1987. The VGA port has 15 pins divided into 3 rows and usually has a blue color. The VGA port carries analog data. Another video port is called the Digital Visual Interface or DVI. And this is a newer technology designed to succeed the older VGA port. It was developed in 1999 and it was designed to provide uncompressed, high-quality video to LCD monitors. And the newest video port is called HDMI, which stands for High Definition Multimedia Interface. HDMI was developed in 2002, and it was designed for transmitting uncompressed video and audio digital data through a single cable. HDMI is a de facto standard for high definition in consumer electronics, delivering crystal clear video and audio. A sound card is another type of adapter card that processes audio through the computer's speakers. A sound card attaches into the computer's motherboard through a bus slot. A basic sound card has an audio output port for attaching speakers and an input port for a microphone for recording purposes. More sophisticated sound cards have extra ports. For example, ports for subwoofers and surround sound, and ports for other digital audio equipment. Other adapter cards include input-output cards. These include FireWire and USB cards. A FireWire card is an input-output card with a FireWire port. So if a computer doesn't have any FireWire ports, or if you wanted to add extra FireWire ports to your computer, you can insert this card into your computer's motherboard and add FireWire capability. Another input-output card is a USB card. Like FireWire, this is used to add extra USB ports to a computer. Now, since the USB port is so popular, and a lot of peripherals are made to use the USB port, usually a computer will have enough USB ports to suit a typical user's needs. But if you're the kind of user that needs more, you can insert a USB card to add more USB ports. There are also adapter cards for storage. For example, a RAID card. You can install a RAID card on a computer and implement a hardware RAID array for data redundancy. It's important to note that in a hardware RAID setup using a RAID card, the operating system is not aware of a RAID implementation. The RAID configuration is done strictly through the RAID card. We'll talk about RAID in an upcoming lesson. And there is also eSATA cards or external SATA cards. This card is used for adding external SATA ports to a computer, so you can add external SATA hard drives, which is mainly used for backing up and storing data. Another type of adapter card is a network interface card, or NIC, and this is used to connect a computer to a network by using an Ethernet cable. It's basically a circuit board with a network adapter that is installed on your computer, and its job is to convert serial data into parallel data so the computer can understand it. A NIC provides a computer with a constant dedicated connection to a network. And each network card has its own unique identifier, called a MAC address. A wireless network card does the same thing that a wired card does, except that a wireless card does not use a cable to connect to a network. Instead, it uses a wireless connection. It has a built-in antenna that is used to wirelessly connect to a network to send and receive data. Now this is very convenient for computers that can be placed anywhere in different locations in a home or office without the hassle of messing with cables. Some laptops have an external slot that is used for inserting a PC card. A PC card is an expansion card for laptop computers. It was originally called a PCM-CIA card, which stands for Personal Computer Memory Card International Association, which is the form factor of a peripheral interface designed for laptop computers. The PC card just slides into the external slot, giving the laptop computer added capability, such as a Wi-Fi card, a network card, or a modem card. RAM or random access memory is temporary memory, and it's installed on the motherboard in the memory slots. A motherboard can have a various number of memory slots. The average motherboard will have between 2 and 4 of them. Memory slots come in different types, depending upon what type of RAM it accepts. For example, most motherboards have DIMM memory modules because it's the most common type to date. DIMM stands for Dual Inline Memory Module. A DIMM memory module has either 168, 184, or 240 pins. A DIMM is a dual inline module because it has two independent rows of these pins, one on each side. And DIMMs have a 64-bit data path. Another type of memory module is a SIMM. SIMM stands for Single Inline Memory Module. A SIMM is an older technology and has since been replaced by the much faster DIMM. A SIMM also has pins on both sides like a DIMM, but in a SIMM, the pins are redundant, compared to a DIMM, which are independent. A SIMM will either have 32 or 72 pins, and a 32-bit data path. Another type of memory module is called RAM, which stands for Rambus Inline Memory Module, which was developed by the company Rambus Inc. RIMs have 184 pins and look similar to a DIMM, with the exception that the bottom notches are located in the center of the module. In 1999, RIMs were a breakthrough in the speed of memory, but has quickly fallen behind due to the advancement of technology in DIMMs. Now the term 32 or 64-bit data path refers to the number of bits of data that are transferred in one cycle. The more bits that are transferred in one cycle, then the faster the computer will be. A single bit or 1 bit of data is the smallest form of data that the computer reads, because in the computing world, a computer only understands ones and zeros, which is represented by a single bit of data. Now there's also the term byte, and 8 bits is equal to 1 byte. So if a memory DIMM is rated to have a 64-bit data path, then that means that it has an 8-byte wide data path or bus, because 64 divided by 8 equals 8. And if a memory SIMM that is rated to have a 32-bit data path, then that means that it has a 4-byte wide bus, because 32 divided by 8 equals 4. So that's why DIMMs are faster than SIMMs. Now this information will be useful in an upcoming lesson on how we determine the exact bandwidth of memory modules. Printers allow the ability to print copies of documents or pictures onto paper from a computer. There are several different ways that a computer can connect to a printer. The most common way is by using a USB or parallel cable. This is known as a local connection because the printer is directly connected to the computer. But you can also connect a printer through a network if the printer has a network interface, such as an Ethernet port or a wireless antenna. These are known as network printers. Network printers are convenient because the printer can be placed anywhere in a home or office as long as it's connected to the network. Another method of connecting is through a network share. For example, you can allow other computers that are on your network connect to your local printer by sharing your printer over the network. So after the printer share setup is complete, the other computers can now print to the printer that is connected to your computer. So your computer basically acts as a gateway for other computers to access your printer. But the drawback is that your computer has to be on in order for others to use your printer. There are several different types of printers. There are non-impact printers and impact printers. Non-impact printers print without striking an ink ribbon onto paper. These include laser, inkjet, and thermal printers. Impact printers are dot matrix printers, which we'll talk about shortly. Inkjet printers are the most common printers that are used for home use. An inkjet printer works by the printhead moving back and forth across the paper during printing. During this process, the printhead places ink on the paper in very tiny dots. In fact, these dots are so tiny that they are smaller in diameter than a human hair. And as these dots are precisely placed, they form to create an image on paper. Inkjet printers typically come with two ink cartridges. One is for color and the other is for black. Inkjet printers are more affordable than laser printers, and they can produce photo quality results. But one of the drawbacks is that the ink from an inkjet printer may smudge, while ink from a laser printer does not smudge. The next printers we're going to talk about is laser printers. Laser printers come in different sizes, from small personal ones to larger ones for businesses. Laser printers provide the highest quality print available today, and they are the most expensive. A laser printer basically works by placing an electric charge on a rotating drum. Then a laser discharges a lower electrical charge on the drum. So basically, the laser draws the image that is going to be printed on the drum itself. Then the drum is coated with a fine black powder known as toner. And as the drum is being coated, the toner only clings to the areas where the laser has drawn. Then as the paper goes through the printer, the toner is placed on the paper. And the result is a high-quality print that is second to none. Another non-impact printer is called a thermal printer. Thermal printers print by using heat. Thermal printers use special print paper called thermal paper. And on this thermal paper is wax-based ink. And when heat is applied to this ink, it turns black. So in a thermal printer, the only thing the printhead does is apply heat to the areas where the ink should be placed. Then, when the ink is cooled, it becomes permanent. And because of this technology, thermal printers are very quiet. Thermal printers are commonly used for printing labels and barcodes. Dot matrix printers are almost non-existent today. They are an old technology that produces mediocre print quality when compared to laser or inkjet printers. And they are also very noisy. Dot matrix printers are impact printers. The printhead in a dot matrix printer moves across the paper, and as it moves, the pins on the printhead strike against a cloth ink ribbon, which then comes in direct contact with the paper, producing each character in the form of dots. But despite being an outdated technology, dot matrix printers can print multi-copy documents, such as carbon copies. They are also very durable and last a long time. Cooling is very important to a computer. Computers generate a lot of heat, and if the components of the computer are not adequately cooled, the computer will overheat. And if it overheats, the computer will either run slow, lock up, or shut down. and will eventually shorten the life of the computer because heat is an enemy to a computer's longevity. Two of the biggest heat generators come from the CPU and the video card. So the main way to adequately cool the computer is with case fans. Case fans are mounted inside the computer case. A basic case fan setup will include at least two fans. One fan that is mounted in the front of the computer is the intake fan. The intake fan is for drawing in cool air from outside the case to inside the case. The other fan is the exhaust fan, which is located in the back of the case, and it's designed to push air outside the case. And once these fans are in place, they're designed to work with each other to create a constant flow of cool air coming into and outside the computer to cool the computer components. So the cool air comes in, cools the computer components, and as the air makes contact with the hot components, the air naturally gets warmer and is then drawn outside the case. And then the cycle starts all over again to create a constant circulation. And this type of cooling is known as active cooling. The biggest heat generator in a computer is the CPU. As stated before, the CPU is the brain of the computer, and it produces an enormous amount of heat in a very short amount of time. In fact, if a CPU were to run by itself without any extra cooling components, the CPU will likely fry itself within 10 seconds. So to remedy this problem, a CPU needs a heat sink to help dissipate the heat. A heat sink is basically an aluminum block with fins that directly makes contact with the CPU, and its purpose is to increase the surface area of the CPU so that it can make more air contact for cooling. The larger the heat sink, the larger the surface area will be, thus increasing the cooling ability. The fins on a heatsink are designed to further increase the surface area for air circulation. Once the heatsink makes contact, the heat will transfer from the CPU where the air can cool the heatsink, which will cool the CPU. And this type of cooling is known as passive cooling. It's important that the heatsink and CPU make the most contact with each other so that adequate cooling can take place. So that's why it's important to apply thermal compound on the CPU before attaching the heatsink. Thermal compound is used to fill in the microscopic air gaps between the heatsink and the CPU to make up for the imperfections of the flat surfaces. The surface areas between the CPU and the heatsink are flat, but they are not perfectly flat when examined with a microscope. The thermal compound is designed to fill in these gaps so that the most contact can be made between the two. A newer type of cooling is water cooling. Instead of using air, this type of cooling uses water to cool the computer components. For example, here is a water cooling unit for the CPU. There is a pump, hosing, and a radiator. And inside this unit is water. The unit is placed directly on top of the CPU, just like a traditional heatsink. And the pump inside constantly circulates the water throughout the entire unit to keep the CPU cool. Once the water reaches the radiator, the water is air-cooled by a radiator-mounted fan that draws air into the radiator and cools the water. This cycle is repeated so a constant flow of cool water makes contact with the CPU. And the end result is that water cooling units cool components far better than air cooling. And they are much quieter. But at the same time, water coolers are more expensive. In Section 1, we talked about secondary memory, which is permanent storage. This dealt with hard drives. Now we'll talk about primary memory, or temporary storage. This is called RAM. RAM stands for Random Access Memory. In order for data or a program to run, it needs to be loaded into RAM first. So here is how it works. The data or program is stored on the hard drive. Then from the hard drive, it is loaded into RAM. And once it's loaded into RAM, the CPU can now access the data or run the program. Now, a lot of times, if the memory is too low, it might not be able to hold all the data that the CPU needs. And when this happens, then some of the data has to be kept on the hard drive to compensate for low memory. So instead of data going from RAM to the CPU, it has to do extra work by going back to the hard drive. And when this happens, it slows down the computer. So to solve this problem, all you need to do is increase the amount of RAM on the computer. And by increasing the memory, all the data can be loaded into RAM without the need of constantly accessing the hard drive. And the result is a faster performing computer. RAM requires constant electrical power to store data, and if the power is turned off, then the data is erased. RAM is stored on the motherboard in modules called DIMMs. These DIMMs come in different memory sizes. Today, they range anywhere from 128 megs to 4 gigs of memory per DIMM or more. RAM also comes in different types, such as dynamic RAM or DRAM. DRAM is memory that contains capacitors, and because it has capacitors, it has to be refreshed often. SRAM stands for synchronous RAM. This memory uses transistors and does not have to be refreshed, unlike DRAM. And because of this, it is much faster than DRAM, and it is also very expensive. An example of SRAM would be the memory cache level 1 and 2 that is used by the CPU. Another type of memory is called SDRAM, which stands for synchronous DRAM. This type of memory is what is used today in RAM DIMMs. The difference between SDRAM and DRAM is basically speed. The older DRAM technology operates asynchronously with the system clock, which basically means that it runs slower than the system clock because its signals are not coordinated with it. But SDRAM runs in sync with the system clock, which is why it is faster than DRAM. All the signals are tied to the system clock for a better controlled timing. SDRAM is rated at different speeds. For example, a stick of SDRAM could be labeled PC100. The 100 equals the speed at which it operates, which is 100 megahertz. And since SDRAM only comes in 64-bit modules, it has an 8-byte wide bus, because 64 divided by 8 equals 8. So to figure out the total bandwidth of PC100, you multiply 100 megahertz times 8 bytes, which equals 800 megabytes per second. So the total bandwidth of PC100 equals 800 megabytes per second. So an SDRAM module labeled PC133, you multiply 133 by 8 bytes, which equals 1066. So the total bandwidth for PC133 equals 1066 megabytes per second. As technology increased and processor and bus speeds have gotten faster, a new RAM technology was developed to keep up with the faster speeds of computers. This newer technology was called DDR, which stands for double data rate. And that's basically what DDR does. It sends double the amount of data in each clock signal when compared to non-DDR RAM. Non-DDR or single data rate RAM uses only the rising edge of the signal to transfer data. But DDR uses both the rising and falling edges of the clock signal to send data, which makes DDR twice as fast. DDR is also labeled differently than non-DDR RAM. Instead of including the clock speed in its name, like PC 133, where 133 equals the clock speed, DDR uses the total bandwidth instead. For example, a DDR DIMM labeled PC 2700, the 2700 is not the clock speed, but it's the actual total bandwidth. The clock speed for PC 2700 is 333 MHz. So 333 MHz times 8 bytes is rounded off to 2700 megabytes per second, which is where we get the name PC 2700. Another example is PC 3200. PC 3200 has a clock speed of 400 MHz. So 400 times 8 equals 3200, which is where we get the name PC 3200. A new technology that has succeeded DDR is DDR2. DDR2 is faster than DDR because it allows for higher bus speeds, and it also uses less power than DDR. A DDR2 DIMM has 240 pins, compared to 184 pins on DDR. Some examples of DDR2 are PC2 3200 and PC2 4200. And the latest RAM technology is called DDR3. DDR3 is twice as fast as DDR2, with a bandwidth of over 12,800 megabytes per second. Like DDR2, a DDR3 DIMM also has 240 pins, but the notches in the DIMMs are in different places. So you can't put a DDR3 DIMM in a RAM slot made for DDR2. In fact, motherboards are made to support a certain type of memory, so you can't mix DDR1, 2, or 3 on the same motherboard. Some examples of DDR3 are PC3 8500 and PC3 12800. Another type of memory was called RDRAM, which was developed by Rambus Inc. And they developed the RIM, which stands for Rambus Inline Memory Module. RIMs have 184 pins and look similar to DIMMs, with the exception that the bottom notches are located in the center of the module. In 1999, RIMs were a breakthrough in the speed of memory, but has quickly fallen behind due to the advancement of technology in DIMMs. When RDRAM debuted in 1999, it ran at 800 MHz, which was considerably faster than SDRAM, which ran at 133 MHz at that time. But even though it was a lot faster than SDRAM, RDRAM only had a 2-byte wide bus, compared to SDRAM, which had an 8-byte wide bus. So if you multiply the speed of RDRAM, which was 800 MHz, times the bus width, which was 2 bytes, you would get a total bandwidth of 1600 megabytes per second. RIM technology was designed to work with a continuous signal, which means that all the other memory slots on the motherboard must be used for RIMs to work properly. And if other RIMs are not available, then a user can install a CRIM or continuity RIM, which is basically a dummy RIM to ensure continuity in all the memory slots. To meet the higher demands of faster processors and memory controllers, a new technology was developed called dual-channel mode. Dual-channel mode requires a pair of identical DIMMs installed on the motherboard, which allows the memory controller the ability to communicate with two DIMMs simultaneously, which increases the speed of accessing the memory. In order for dual channel to work, the motherboard must be equipped to work in dual channel mode, and the memory DIMMs must be identical to each other in speed, size, and features. Then the DIMMs must be inserted into the motherboard in a specific slot configuration in order to enable dual channel mode. Typically, the memory slots will be color-coded to help assist in identifying where the DIMMs should be inserted. For example, here we have some dual channel memory slots. So in order for dual channel to work, you need to install a pair of identical DIMMs in the slots of the same color. In this case, we put a pair of DIMMs in the yellow slots. Some RAM modules have ECC, which stands for Error Correcting Code. And what this does is that it detects if the data was correctly processed by the memory module, and makes a correction if it needs to. You can tell if a RAM module has ECC by counting the number of memory chips on the module. In a standard non-ECC DIMM, it will have 8 memory chips, but in an ECC module, it will have 9 memory chips. Most RAM modules today are non-ECC, and this is because of the advance in technology that has minimized memory errors and has made non-ECC RAM more stable. Typically today, ECC memory is mostly used in servers because servers need to be up and running at all times, and using ECC memory is just an extra precaution to guard against any memory errors. The processor socket is the place on the motherboard where the CPU is placed. The socket is a square plastic or metal holder with multiple holes to accommodate the pins on the bottom of the processor. As these holes and pins make contact, they provide physical and electrical contact between the motherboard and the CPU. Modern CPU sockets are called ZIFs, which stands for Zero Insertion Force, which basically means that the CPU is installed in the socket with no force. It just drops in the socket easily. There are different types of CPU socket designs called packages. One of the most common types of these packages is the PGA, or Pin Grid Array. The PGA package is a typical square ZIF socket design with holes and a lockdown lever as stated previously. There are several different sockets that use the PGA package. For example, Socket 1, which came out in 1989, this socket had 169 pins and used the Intel 486 processor. Another example is the Socket 370, which had 370 pins and it used the Intel Pentium 3 processor. Other examples include the Socket A, Socket 754, and Socket 939, just to name a few. In fact, there are over 25 different sockets that utilize the PGA package. Another type of socket design is the slot package. Now this package design is very different from the PGA. In a slot package, the CPU utilized a type of expansion slot interface called SECC, which stands for Single Edge Contact Cartridge. The CPU is housed inside a plastic cartridge and then inserted into the motherboard in a slot very similar to inserting an expansion card. The slot design is an older design that made its debut with the Intel Pentium 2 processor, which came out in 1997. This particular design was called Slot 1. The latest in socket design packages is called LGA, which stands for Land Grid Array. The LGA socket is a metal casing with a door that closes over the CPU and locks down with a lever. Unlike previous socket versions, which have holes, the LGA has pins that make contact with the bottom of the processor. LGA processors don't have pins. Instead, they have pads that rest on the LGA socket pins. Some versions of the LGA socket are the LGA 775, which has 775 pins. This socket was designed for processors like the Intel Pentium 4 and Pentium dual cores. Other LGA sockets include the LGA 1156 and LGA 1366, which have 1156 and 1366 pins respectively, and these were designed for the high-end processors such as the Intel Pentium Core i7. The Central Processing Unit, or CPU, is the main component on the motherboard. It's the brain of the computer where all the data processing takes place. It's in charge of executing program instructions and logical calculations. The CPU is the largest component on the motherboard. It's a square chip that is inserted into the motherboard in a plastic or metal holder called a CPU socket. And directly on top of a CPU is the heatsink and fan, and these are used to keep the CPU from overheating. The speed of the CPU is measured in megahertz. For example, 1 megahertz equals 1 million cycles per second. 500 megahertz equals 500 million cycles per second. And 1 gigahertz equals 1 billion cycles per second, and so on. Today's high-end processors average a speed of over 3 gigahertz per second. Inside the processor is the core. The core is where the reading and execution of instructions take place. A processor that has a single core processes instructions one at a time. But today's higher-end processors have more than one core. These are called multi-core processors, and they can process more instructions than a single-core processor, which gives a multi-core the ability to multitask and have a greater overall performance. Some examples of a multi-core processor are dual-core processors, which has 2 cores. Another example is a quad-core processor, which has 4 cores. Two of the biggest manufacturers of processors are Intel and AMD. Intel, being the largest manufacturer of processors, was founded in the late 60s and has since dominated the CPU market for a number of years until the rise of AMD started to become its chief competitor. Some of the Intel processors are known as the 286, 386, 486, Celeron, and Pentium processors. Advanced Micro Devices, or AMD, is the second largest manufacturer of processors. AMD was also founded in the late 60s, but it didn't really start to compete with Intel in the CPU market until the mid-1990s. Some of the AMD processors are known as the K5, K6, Athlon, Duron, and the Sempron processors. Their higher-end processors include the Athlon 64, Opteron, and Phenom. CPUs can come in 32 or 64-bit versions. The difference between a 32-bit and a 64-bit is the way that it handles memory. The bit size of the CPU refers to the memory it can address. A 32-bit CPU can reference 2 to the 32nd power bytes of memory, which equals about 4 gigabytes. However, a 64-bit CPU can reference 2 to the 64th power bytes of memory, which equals to about 16 exabytes, which is 4 billion times more memory than a 32-bit. Now that number is so huge that it's virtually unlimited because we will never need to use that amount of memory. So going back to what we stated before, in order for data or program to run, it needs to be loaded into RAM first. So the data is stored on the hard drive, then from the hard drive it is loaded into RAM. And once it's loaded into RAM, the CPU can now access the data or run the program. Now in a 32-bit system, since the maximum amount of memory it can support is 4 gigabytes, it may not be enough to hold all the data that the CPU needs to make the computer run as fast as possible. And when this happens, then some of the data has to be kept on the hard drive to compensate for the low memory. So instead of data going from RAM to the CPU, it has to do extra work by going back to the slower hard drive. And when this happens, it slows down the computer. But in a 64-bit system, it's able to store a lot more memory than 4 gigabytes, which means that more data can be loaded into the faster RAM than on a slower hard drive. And because it can store more data on the faster RAM than on a slower hard drive, the computer is able to run a lot faster. So in a nutshell, this is why a 64-bit system is faster than a 32-bit system. There's also what's called memory cache. The memory cache is made of SRAM or static RAM, which is very fast memory when compared to regular DRAM that is used for primary memory. The memory cache is the processor's internal memory, and its job is to hold data and instructions waiting to be used by the processor. So basically what cache does is that it holds common data that it thinks the CPU is going to access over and over again. Because when the CPU needs to access certain data, it always checks the faster cache memory first to see if the data it needs is there. And if it's not, then the CPU will have to go back to the slower primary memory or RAM to find the data it needs. So that's why cache memory is so important, because if the CPU can access what it needs on the faster cache memory, then the faster the computer will perform. The memory cache comes in different levels. For example, there's level 1 cache, which is also called primary cache. Level 1 cache is located on the processor itself, so it runs at the same speed as the processor. So it's very fast and is the fastest cache memory on the computer. And there is also level 2 cache, which is also called external cache. And level 2 cache is used to catch recent data accesses from the processor that were not caught by the level 1 cache. So in a nutshell, if the CPU can't find the data it needs on the level 1 cache, it then searches the level 2 cache for the data. And if level 2 doesn't have it, then it has to go back to the regular RAM to find the data it needs. Level 2 cache is generally located on a separate chip on the motherboard, or in modern CPUs, it would also be located on the processor. Level 2 cache is larger than level 1 cache, but it's not as fast as level 1 cache. One of the main and one of the most important components you'll find on a motherboard is the chipset. Older motherboards were designed with a lot of different chips scattered all over the motherboard. There were chips for different things, like chips for bus controllers, memory controllers, keyboard controllers, and so on. So they had a lot of different chips controlling different functions on the motherboard. So as technology progressed, computer engineers decided to reduce the number of chips and have them more in a centralized location. So instead of having these different chips scattered all over the motherboard controlling different functions, they reduced the number of chips to do the same job and condensed them to only a few chips, or what's now called a chipset. And that's what a chipset is. A chipset is a smaller set of chips that has replaced a larger amount of chips. And the chipset's job is to control data flow between the CPU, the peripherals, bus slots, and memory. So all of the different parts of the computer communicate with the CPU through the chipset. The chipset basically consists of two chips. One is called the North Bridge, and the other is called the South Bridge. The North Bridge is located in the upper or northern part of the motherboard, providing you're looking at the motherboard in the upright position. It's located near the CPU and is directly connected to the CPU. It's also directly connected to the memory and the AGP and PCI Express slots. So in order for the CPU to communicate with the memory and the AGP or PCI Express bus, it has to go through the North Bridge first. So the North Bridge acts like a communication middleman between the CPU, AGP or PCI Express, and memory. The other chip is called the South Bridge, and the South Bridge is located at the bottom or southern portion of the motherboard, near the PCI bus slots. The South Bridge connects to the PCI bus slots, SATA and IDE connectors, and USB ports. So the South Bridge is responsible for the lower portion of the motherboard, while the North Bridge is responsible for the upper portion. There is no direct connection between the CPU and the lower portion of the motherboard. So if the PCI, USB, IDE, or SATA ports needed to communicate with the CPU, the information has to go through the South Bridge, and then up through the North Bridge, and then to the CPU. The North Bridge is faster than the South Bridge, and that's because the CPU, the PCIe, AGP, and memory are the most used and most important components of the motherboard, so they need to operate at the highest speeds possible. The slower South Bridge communicates with the PCI bus, SATA and IDE connectors, and USB ports, and they don't need to be as fast as the other components. So basically the higher speed components are connected to the North Bridge, and the slower components are connected to the South Bridge. Now both the North and South Bridge make these connections to various parts of the motherboard using pathways called a bus. And a bus is simply a set of pathways that allows data and signals to travel between components on the motherboard. The motherboard contains several kinds of buses that vary in speed and bandwidth. So for example, if a bus speed is said to operate at 66 megahertz, then that means that that particular bus can send data at 66 million cycles per second. The higher the bus speed, the faster the computer can send data, which improves the performance of the computer. A motherboard's bus speed generally refers to the speed of the front side bus. The front side bus is the connection between the CPU and the North Bridge chipset. All motherboards are equipped with input-output bus slots. These are typically located on the bottom rear of the motherboard. These bus slots are also called expansion slots because these slots are used to expand the capability of the computer. For example, if the motherboard doesn't already have a built-in sound card, then you can add a sound card by inserting one into one of these bus slots, giving your computer the ability to produce sound. Or let's say the motherboard doesn't have enough USB ports to suit your needs. Well, then you can add a USB expansion card in one of the bus slots to add more USB ports. Bus slots come in different types. The first ever bus type is called ISA, which stands for Industry Standard Architecture. ISA slots have an 8-bit data path running at 4.7 MHz. ISA slots are old and slow and are not seen on modern motherboards and have been succeeded by the faster PCI slots. A modern bus type today is called PCI, which stands for Peripheral Component Interconnect. PCI has been around since 1993 and was the standard bus slot for modern motherboards until PCI Express came out, which we'll talk about shortly. PCI slots are much faster compared to ISA slots, with a data path of 32 or 64 bits, with speeds ranging from 133 to 533 megabytes per second. They are also about half the physical size and length of the ISA slot. As computers got faster, a lot of people were using their computers for higher-end graphics applications such as gaming. And as computers became more graphically oriented, the PCI slot was lagging behind in delivering computer graphics data. For this purpose, the AGP slot was developed. AGP stands for Accelerated Graphics Port, and it was created to assist in accelerating 3D computer graphics. One of the main reasons why AGP is faster than PCI is because AGP has its own dedicated pathway to the processor, unlike PCI. The AGP port is only used for a video card and is usually a brown color. PCI Express is the latest version of bus slots. It's faster than its predecessor with speeds up to 4 gigabytes per second. And unlike standard PCI, which transfers data in parallel, PCI Express transfers data in serial. Transferring data in serial is much faster than parallel because serial data is transferred in packets. PCI Express was designed to succeed all other PCI bus slots and AGP. And it is not backward compatible with standard PCI because the architecture is very different. There are 4 different slot sizes in PCI Express. There's PCI Express by 1, 4, 8, and 16. PCIe by 1 has 1 lane for data. A lane has 4 wires. 2 are for sending and 2 are for receiving. PCIe by 4 has 4 lanes. PCIe by 8 has 8 lanes. And the fastest slot is PCIe by 16, which has 16 lanes. And PCIe by 16 has succeeded the AGP slot for the video card. Some older motherboards may contain a bus slot called AMR, which stands for Audio Modem Riser. The purpose of the AMR was to allow the manufacturers to create motherboards that didn't have analog input-output functions. By using AMR, this analog function can now be created by inserting an expansion card, such as a modem or sound card, into the AMR slot. This slot was developed by Intel in 1998 and is about half the size of a standard PCI slot. The CNR, or Communications and Networking Riser, is another slot developed by Intel, and it was designed to be an improvement over the AMR. The improvements it had over AMR was that it can be either software or hardware driven, compared to AMR, which was only software. Another improvement was that it was plug-and-play compatible, while AMR was not. But both AMR and CNR are becoming obsolete because of the increasing number of integrated components that motherboards now come equipped with. Parallel ATA, which is also known as eIDE, is an interface standard that is used for attaching drives to a computer, such as hard drives and CD and DVD-ROM drives. It uses a 40-pin ribbon cable that is able to accommodate 2 drives per cable. One drive is a master and the other is a slave. And each drive is designated by a jumper setting. A jumper is just a small short-length conductor that is used to close an electrical circuit. Jumper settings are located on the back of each drive. The jumper settings are either master, slave, or cable select. The drive that is placed on the end of the cable is the master, which will use the master jumper setting. So we'll place the jumper over the 2 pins under master. The other drive is a slave, which uses the slave setting. So we'll place the jumper over the 2 pins under slave. Drives that are set to cable select automatically configure themselves as master or slave according to their position on the cable. Older motherboards came with 2 PATA interfaces, which means you can attach a total of 4 drives to a computer. But the PATA interface is slowly being phased out by the faster SATA interface, and modern motherboards may only have 1 PATA interface or none at all. Now this is the RJ11 connector, and RJ stands for registered jack. This is basically a telephone jack. This is a 4-wire connector used mainly to connect telephone equipment. And as far as networking is concerned, the RJ11 is used to connect computers to local area networks through the computer's modem. The RJ11 locks itself into place by a hinged locking tab. And it resembles the RJ45, but it's a little bit smaller. Now the RJ45 is by far the most common network connector. This is an 8-wire connector and is used to connect computers to local area networks. Like the RJ11, it also locks itself into place by a hinged locking tab. And it resembles the RJ11, but it's a little bit larger. Unshielded twisted pair is by far the most common type of cable that is used today. It consists of 4 pairs of unshielded wires twisted around each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of cabling is mainly used on local area networks. Now shielded twisted pair is very similar to unshielded twisted pair, except that it adds a foil shield that covers the wires. This shielding adds a layer of protection against electromagnetic interference leaking into or out of the cable. Today there are 4 different categories of twisted pair cable. The difference between these is the maximum speed they can handle without having any crosstalk. The numbers of these categories represents the tightness of the twists that are applied to the wires. These categories are 3, 5, 5E, and 6. So category 3 has a maximum speed of 10 megabits per second. Category 5 has a maximum speed of 100 megabits per second. And category 5E and 6 have maximum speeds of 1000 megabits per second. The terms 568A and 568B refer to a set of wiring standards developed by TIA/EIA, also known as the Telecommunications Industry Association. These terms define the rules on how twisted pair cables should be wired to RJ45 connectors. and these wires must follow a certain order so that the network can function properly. The 568A standard is wired in this order: white-green, then green, white-orange, blue, white-blue, orange, white-brown, and brown. The 568B standard is wired in the following order: white-orange, then orange, white-green, blue, white-blue, green, white-brown, and brown. There is no difference in the functionality as to which standard is used. The term plenum refers to a space in a building where there is open airflow circulation. This is usually between the drop ceiling and the structure ceiling. Buildings that don't have plenum spaces have air ducts encapsulating the airflow. So as a result, buildings that have plenum spaces where there is adequate open airflow are more prone to fires than buildings that don't have plenum spaces. And because of this, cables that run through plenum spaces must meet certain requirements. First, they must be more fire resistant. And secondly, they must not produce toxic fumes if they are burned. The BNC connector is a common type of RF connector that is used on coaxial cable. BNC stands for Bayonet Neo Consoleman, and it is used for both analog and digital video transmissions, as well as audio. Now this connector is called the F-type. Now this is a threaded connector typically used on coaxial cables. These are primarily used by cable providers to attach to cable modems. The F-type hand tightens by an attached nut. This is a coaxial cable. This is used today primarily by cable providers to provide a computer with broadband internet connection. Early on, it was used as a backbone for networks, such as a bus network. There are two common types of coaxial cable that you would need to know for the exam. The first is RG6. This is made for long distances and is commonly used for cable television and internet connection. The second type is RG59. This is made for short distances and is commonly used for high definition and high quality video. Now we're getting into fiber optic cables. Here is a cutaway view of a fiber optic cable and a light source. Fiber optic cable uses pulses of light to send data. As a result, it is very fast and can span for great distances. There are two different modes in fiber optics: single mode fiber and multi-mode fiber. Single mode fiber is a fiber optic cable that allows light to enter only at a single angle, as you can see here. So when this type of transmission of light enters at this angle, it can span for great distances. Now this is multi-mode fiber. The difference between multi-mode and single mode is that in multi-mode, light travels in multiple beams that reflect off the walls of the cable. And unlike single mode fiber, multi-mode fiber is made for short distances. Our next fiber optic connector is called the ST, or straight tip. This uses a half-twist bayonet type of lock and is commonly used with single mode fiber optic cable. Our next connector is called the LC, or local connector. This is also a fiber optic connector. It uses a jack similar to the RJ45. This type of connector is commonly used between floors on a building. And our last fiber optic connector is called the SC, or standard connector. This uses a push-pull connector similar to audio and video plugs. And like the LC connector, this is also commonly used between floors on a building. IP address is a numeric address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. The IP address consists of two parts. The first part is the network address, and the second part is the host address. There are two different types of IP addresses. The first one is the most common one. It's called IP version 4. The second type is called IP version 6. IP version 4 is the current version of IP addresses. It's a 32-bit numeric address written as 4 numbers separated by periods. Each group of numbers that are separated by periods are called octets. The number range in each octet is 0 to 255. This address version can produce over 4 billion unique addresses. When the Internet was first developed, programmers didn't realize how big it will become. They thought that IP version 4, which produced over 4 billion addresses, would be enough, but they were wrong. IP version 6 is the next generation of IP addresses. The main difference between IP version 4 and IP version 6 is the length of a network address. The IP version 4 address is a 32-bit numeric address, whereas IP version 6 is a 128-bit hexadecimal address. Hexadecimal uses both numbers and alphabets in the address. So with this type of address, IP version 6 can produce over an unbelievable 340 undecillion IP addresses. That's the number 340 with 36 zeros after it. So as you might have guessed, IP version 6 is more than enough for the foreseeable future. As stated previously, an IP address has two parts. One part is designated for the network, and the remaining is designated for the host. So the way to tell which portion belongs to either the network or the host is where the subnet mask comes in. A subnet mask is a number that resembles an IP address. It reveals how many bits in the IP address are used for the network by masking the network portion of the IP address. So in this subnet mask, the first two octets are 255. And if we were to look at this subnet mask in binary form, the first two octets would be all ones. Because when you count all the numbers in an octet, it will equal 255. Now let's go ahead and add our IP address with its binary form. So the way to tell which portion of this IP address is the network portion is when the subnet mask binary digit is 1, it will indicate the position of the IP address that defines the network. So we'll cross out all the digits in the IP address that line up with the ones in the subnet mask. And when you do this, it will reveal that the first two octets are the network portion, and the remaining is the host portion. Here is a chart for the default subnet masks for a class A, B, and C IP address. Notice the change of the location of the network and host portions between them. You are going to need to memorize the default subnet mask classes for the exam. IP addresses are assigned to different organizations in blocks. These blocks are divided into 5 classes, but for the exam, you only need to know 3 of them. They are Class A, Class B, and Class C. You can tell by the number in the first octet which class an IP address belongs to. So a Class A IP range is from 1 to 126. This class supports 16 million hosts on 126 networks. So this class is mainly given to large organizations because of the tremendous amount of IP addresses it can give out. A Class B IP range is from 128 to 191. This class supports 65,000 hosts on 16,000 networks. This class is given to medium-sized organizations. And a Class C IP range is from 192 to 223. This class supports 254 hosts on 2 million networks. This class is given to small organizations. Now if you notice, we skipped over the 127 range. This number cannot be used for a network because the 127 address is reserved for internal loopback functions. You're also going to need to memorize the default subnet masks for each of these classes. Every computer on a network has to have an IP address for communication purposes. There are two ways that a computer can be assigned an IP address. It can be done either by using a dynamic IP or a static IP. A dynamic IP is where a computer gets an IP automatically from a DHCP server. DHCP stands for Dynamic Host Configuration Protocol. A DHCP server automatically assigns a computer with an IP address. In addition to an IP address, it can also assign a subnet mask, default gateway, and a DNS server. Here we have the TCP/IP properties window open for the network interface card on a Windows XP machine. As you can see, this computer is set to obtain an IP address automatically. So when you choose this option and press OK, the computer will send out a request for an IP address. Then the DHCP server will assign an IP address from its pool and deliver it to the computer. Dynamic IP addressing is the best choice because it makes managing a network a lot easier. You can also assign a computer with an IP address manually. This is called a static IP. A static IP is where a user manually assigns an IP address for the computer, so there is no need for a DHCP server. This kind of IP addressing is also known as permanent, because unlike dynamic IP addressing, where the IP address can change automatically, a static IP only changes if the user decides to. When a computer is set to automatically obtain a dynamic IP address, it gets the IP from the DHCP server. But what happens if this computer cannot reach a DHCP server? For instance, what happens if the DHCP server goes down, or if the connection to the server is lost? If this happens, then the computers that are running Microsoft Windows 98 or later, the computer itself will assign its own IP address. This IP address will be in the 169.254.0.0 network. This type of self-assigned addressing is called API-PA, which stands for Automatic Private IP Address Assignment. Computers running Microsoft Windows 98 or later do this so that they can still be able to communicate with the other computers on the same network that also have self-assigned IP addresses. If a DHCP server later becomes available, the computer changes its IP address to one that's obtained from the DHCP server. When data is sent over the internet to your computer, it needs to know how to accept it. And your computer accepts this data using ports. And these ports are categorized by two protocols, TCP and UDP. Now a port is a logical connection that is used by programs to exchange information. And these ports have a unique number that identifies them. The number ranges from 0 to 65,535, but of these 65,000, you only need to memorize a few of them, and these few are called well-known ports. So here is a chart of the well-known ports that should be memorized. These are the most common ports that an average person uses on a daily basis. such as web and email. So for the exam, you're going to need to memorize this chart. Memorize the associated port number with the application, and if it's a TCP or UDP port. Transmission Control Protocol is one of the main protocols used in a TCP/IP network. This is a connection-oriented protocol, which means that it must first acknowledge a session between the two computers that are communicating. It does this by using a three-way handshake. The first step is that a computer will send a message called a SYN, S-Y-N. Then the receiving computer will send back an acknowledgement message telling the sender that it has received the message. And finally, the sender computer sends another acknowledgement message back to the receiver. Once this has taken place, data can be delivered. Another important thing to remember about TCP is that it guarantees the delivery of the data. So if a data packet does go astray and doesn't arrive, then TCP will resend it. Now UDP is very similar to TCP. UDP is also used for sending and receiving data, but the main difference is that UDP is connectionless, which means that it does not establish a session and does not guarantee data delivery. So if a computer sends their data, it doesn't really care if the data is received at the other end. That's why UDP is known as the fire and forget protocol, because it sends data and it doesn't really care what happens to it, as this demonstration will show. Another point to remember is that because of the less overhead that's involved of not guaranteeing data delivery, UDP is faster than TCP. This is Lightweight Directory Access Protocol. This is used to get information from a server. To be more specific, it is used for accessing and modifying directory services such as email addresses. SMB stands for Server Message Block. This is used on Microsoft-equipped computers, and it enables a user to access shared files on servers that are using Linux and Unix operating systems. DNS stands for Domain Name Service. Now this resolves domain names to IP addresses. In the world of networking, computers don't go by names like humans do. They go by numbers. So if you type a web address in your browser, DNS will transform the name to a number, because all computers know is numbers. So for a demonstration, when you type in yahoo.com in your web browser, the DNS server will search through its database to find a matching IP address for that domain name. And when it finds it, it will transform that domain name to the IP address of the Yahoo web server. So DNS basically works like a phone book. When you want to find a phone number, you don't look up the number first. You look up the name first. Then it will give you the number. FTP stands for File Transfer Protocol. This is the standard protocol that is used by web users to upload and download files between computers through the internet. So if a user wanted to make their files available to download to other users, all they would have to do is simply upload their files to an FTP server, and a user can simply download them. Now there are a few ways to transfer files using FTP. You can use your standard internet browser, or you can use special FTP software. It's also important to note that FTP is a connection-oriented protocol that uses TCP for file transfer. Now secure FTP is just like FTP, except that it adds a layer of security. The data using secure FTP is actually encrypted using secure shell during data transfer, so no sensitive data like passwords are sent in clear text. This is called Network Address Translation, or NAT. This is a service that is typically used in routers, and this is used to translate a set of IP addresses to another set of IP addresses. So for example, here we have a private network, and it's using a set of private IP addresses internally. Over here we have the router with its public IP address, and this router is running the NAT service. If a computer in this network wanted to communicate over the internet, it needs to translate its private IP address to the internet's public IP address. And this goes both ways. If a computer on the internet wants to communicate with a computer on this private network, then the public IP address needs to be translated to the private IP address for that computer. This is called Simple Network Management Protocol. This is a protocol used for network management. It's basically used for collecting data from various network devices, such as routers, printers, and servers. SSH, or Secure Shell, is a better alternative to Telnet. Secure Shell protects the data from being attacked or stolen as it's being transferred over a network. So for example, if you were sending sensitive data, like a login and password, a potential hacker could be listening and steal the data. That's the reason for Secure Shell. Secure Shell acts like a secure tunnel that forms around the data transfer and protects it from potential threats. Next, we're going to talk about SOHO routers, which stands for Small Office Home Office Router. And these are your common inexpensive routers that are used in homes and small businesses. These are fairly easy to set up, but if you don't configure the router correctly, you will not have access to the network. To set up and configure your SOHO router, you need to go into the router's built-in configuration web page. So you would just open up a web browser, and in the address field, you would type in the router's IP address. So for example, our router has an IP address of 192.168.2.1. And once you type that in, you press enter on your keyboard, and now you're in. So here's an example of the configuration page for a Cisco SOHO router. And this is where you would set up the router with custom settings to make it work for your particular network. So for example, like most SOHO routers, this one has a DHCP server built into it. And as you recall, a DHCP server automatically assigns an IP address to each computer on your network because all computers need an IP address to function on a network. So by default, the DHCP server is enabled. But if you want to, you can disable the DHCP server by pressing this button here, and then just save your settings. Also in a router's web page, there are the wireless settings. Now in here, you can configure the wireless settings for your network. For example, you can set the SSID, which stands for Service Set Identifier, which is basically the name of your wireless network. The SSID is shared among all wireless devices in your network. The SSID is customizable, and you can call it whatever you want. And as you can see here, this SSID is called My Wireless. So as an example, when a wireless laptop scans for wireless networks to join in the vicinity of this router, the laptop will see the router's SSID broadcast called My Wireless, and if it has the proper credentials, it can join the network. Also in here, you can set the channel for your wireless network. And channels are used to avoid interference with other wireless networks nearby. So if you are experiencing any connectivity issues to your wireless router, there might be interference with another nearby wireless network that's operating on the same channel as yours. So in this case, you can try changing to a different channel and see if it solves your problem. And if you click on the wireless security section, you can configure the security of your wireless network. So here you can choose to disable security and have your network wide open, or you can choose to secure your network with one of these security modes. And as you can see, this router supports the following security options, such as WEP, WPA, and WPA2. Wired equivalent privacy is one of the security protocols that are used for wireless networks. As the name implies, it was meant to supply the same security to wireless networks as it did with wired networks. But unfortunately, this turned out not to be the case. After a short period, it was found out that the 40-bit encryption key that WEP uses was not secure, and it was easily hackable. So a better protocol was needed for wireless networks. WPA is another wireless security protocol that was developed to solve the security problems of WEP. WPA is far better than WEP in two ways. First, it uses a stronger encryption method using TKIP, which stands for Temporal Key Integrity Protocol, which dynamically changes keys as it's being used. This ensures data integrity. And secondly, WPA uses the Extensible Authentication Protocol, which verifies authorized network users. Building on the security of WPA, WPA2 was developed to provide even stronger security than WPA. And it does this by requiring the use of a stronger wireless encryption method. While WPA uses Temporal Key Integrity Protocol for encryption, which has known to have some limitations, WPA2 uses CCMP for encryption. And CCMP is more secure because it uses an enhanced data cryptographic encapsulation mechanism. And since 2006, WPA2 is available on all certified Wi-Fi hardware. And our last wireless security protocol is WPS. WPS stands for Wi-Fi Protected Setup, and this security protocol was designed for users who know little about wireless networks to make it as easy as possible for them to join a secure wireless network. So here's an example of a WPS configuration page for our router. And as you can see, there are 3 different WPS methods that you can use to join this wireless network. So you could use method 1 if your client has a Wi-Fi protected setup button. You would just press that button, then within 2 minutes you would press the WPS button here on this page, or you can just press the physical WPS button on the router itself and then you'll be connected. You can also use method 2 if your client has a WPS PIN number. You would just enter that number in here and press register. Or you can use method 3 if your client asks for the router's PIN number, and you would just enter this number into your device and then you'll be connected. So as stated before, WPS is the easiest way to join a wireless network, and a lot of manufacturers are building their wireless products with WPS to make it as simple as possible for their customers to join their device to a wireless network. Another wireless security is the MAC filter. Every wireless adapter has a MAC address. A MAC address is a hexadecimal number that uniquely identifies each device on a network. And with the MAC filter, you can either prevent or permit access by using the device's MAC address. So in this example, once we enable the MAC filter, we can choose the option to prevent devices that are listed below from accessing the wireless network. So all of these devices listed here are now blocked from joining the network. Or the other option, we can choose the permit option, and this will allow only the devices listed below access to the network. There is also what's called the DMZ, and DMZ stands for Demilitarized Zone. And the DMZ allows a designated computer on your network to be fully exposed to the internet. And it does this by the router forwarding all ports at the same time to the designated DMZ computer. So while these computers here on our internal LAN are protected inside the firewall, the DMZ computer is outside the firewall and is not protected. The DMZ is typically used for testing purposes. So if you just set up a computer that you want to be accessed from the internet, and if you're having a problem configuring the firewall and applications so that it can be accessed from the internet, you can simply bypass all firewall security and put the computer in the DMZ temporarily to make sure everything is working until you can pinpoint a problem you are having, such as a firewall setting. It's also important to note that the DMZ computer must be assigned a static IP address and not automatically from a DHCP server. Another option on the configuration page is port forwarding. And on this page, you can customize port services for certain applications. So when a user sends these types of requests to your network from the internet, the router will forward those requests to the appropriate computer. So for example, let's say a friend of yours wants to access one of your computers in your home network using RDP or Remote Desktop Protocol. And as you know from an earlier lesson, that RDP services uses port 3389. So what happens is, when your friend starts up their RDP service on their computer, they put in the public IP address of your router, and once that request hits your router needs to know which computer on your network to forward that request to, so your friend can access the correct computer. So that's where port forwarding comes in. Here on the port forwarding configuration page, you have to forward the RDP port to the correct computer. So you type in the RDP port number, which is 3389, and then you have to point it to the IP address of the computer that you want your friend to access, which is 192.168.2.3. And once that's done, the router knows where to forward that request, and the connection is now complete. DSL stands for Digital Subscriber Line. This is a popular technology that is used by homes and businesses to access broadband data over the internet. The advantage of DSL is that it can carry both data and voice at the same time. It has a DSL modem that uses common telephone lines to carry its data. It's a high-speed connection that is much faster than your regular dial-up modems. Another popular technology that is used to access the internet is broadband cable. Cable is by far becoming the technology of choice by many homes to access the internet. It uses a cable modem with an attached coaxial cable which provides a link to the internet service provider. Like DSL, cable is very fast, with speeds averaging around 3 megabits per second or more. Cable is typically provided by the same provider that supplies cable television to their customers. Satellite communication is pretty expensive and is mainly used where no other services are provided, like phone lines, cable, or DSL. But because of the increasing availability of these other options, satellite is rarely used. The speed of satellite is pretty fast at 1.5 megabits per second, but it's only a fraction of that in upload speeds. Another method of connecting to the internet is by using mobile hotspots. And mobile hotspots are portable devices that use cellular networks to connect wireless devices to the internet. So if there are wireless devices within 30 feet of the mobile hotspot, they can join it and then they will have access to the internet. Mobile hotspots come in two forms. They will either be a freestanding device like you see here, or they can come as a feature built into a smartphone. And mobile hotspots are available through cell phone carriers, such as Verizon, AT&T, T-Mobile, and Sprint. ISDN stands for Integrated Services Digital Network. This is an international standard for digital transmission over ordinary telephone lines. In order to use ISDN, users had to install ISDN modems. This was a significant improvement of speed over the standard modem, because a standard modem sends data at a maximum speed of 56 kbps. But ISDN sends data at 128 kbps. But ISDN never really caught on because of the faster speeds of DSL and cable. The layout of how a network communicates with different devices is called a topology. And the most common topology is the star topology. In a star topology, all computers are connected to a central wiring point, such as a hub or a switch. And all data passes through this central point before continuing to its destination. A ring topology is a type of network configuration where each computer is connected to each other in the shape of a closed loop or ring. So every computer on this ring has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. And unlike the star topology, the ring topology is rarely used today. This is called the bus topology. This is very old technology and it is not used today that much. Now this is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. And this backbone is a coaxial cable. The computers connect to this cable using special connectors called B and C, or also known as T connectors. And this cable has to be terminated at both ends using terminators. In a mesh topology, each computer on the network connects to every other computer or device on the network. So by having so many connections, it handles failure very well. In this illustration, there are 4 computers with 3 connections on each computer, which makes a total of 12 connections for this network. But because of the amount of cabling and network cards that have to be used, mesh topologies can be expensive, so they are rarely used on local area networks or LANs. They are mainly used on wide area networks, like the Internet. In fact, the Internet is a perfect example of a mesh topology. Topologies can also be combined with other topologies if needed. These are known as hybrid topologies. Hybrid topologies can offer the best of both worlds. In fact, a lot of businesses use some form of hybrid topology to suit their growing needs. The most common forms of hybrid topologies are the star ring network and the star bus network. In a star bus network, two or more star topologies are linked together using a single bus connection. And in a star ring network, two or more star topologies are linked together to form a large ring network. The word PAN stands for Personal Area Network, and this is a type of network that is used on a personal level. It's a small network that is basically used for connecting things like mobile phones, PDAs, and laptops to each other using Bluetooth. PANs are generally used for transferring small files, such as music, photos, calendar appointments, and so on. Now a LAN stands for Local Area Network. And a local area network is a group of devices, such as computers, servers, and printers, that are basically located in the same building. In other words, in close proximity to each other. The most common type of LAN is an Ethernet LAN, where two or more computers are connected to Cat5 Ethernet cables using a switch. A MAN stands for Metropolitan Area Network. Now this is a larger network than a LAN. It's a network that spans over several buildings in a city or town. MANs are typically connected using a high-speed connection such as fiber optic cable. And finally, there is the Wide Area Network, or WAN. And a WAN is the largest type of network. It's a network that spans over a large geographical area, such as a country, continent, or even the entire globe. A good example of a wide area network is the Internet. A hub is a device that has multiple ports that accepts Ethernet connections from network devices. A hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where data is supposed to be sent. When a data packet arrives at one of the ports, it is copied to all other ports, so all the devices on that hub sees that data packet. There are also two different types of hubs, passive and active. A passive hub does not require power, but an active hub does require power. Now a switch is very similar to a hub. It's also a device that has multiple ports that accepts connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these addresses in a table. So when a data packet is sent to a switch, it directs it only to the intended destination port. That's the major difference between a hub and a switch. As a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network. Bridges are used to divide a network into separate collision domains. For example, here we have a network, and this network is segmented into two by a couple of hubs. If you notice, all the broadcast traffic from the two segments are seen by all the computers on both sides, and this causes unnecessary traffic. So that is where a bridge can be helpful. If you add a bridge to this network, it will reduce any unnecessary traffic between the two segments by filtering the data based on their MAC address. The bridge only allows data to cross over if it meets the required MAC address of the destination, because a bridge keeps a record of all the MAC addresses of the NICs that are connected to it, and it will also block all data from crossing over if it fails to meet this requirement. Now a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another. When a data packet is received from the router inspects the packet and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway for a network. Now let's go ahead and demonstrate this. Here we have a private network with its router. We'll refer to this one as the red network, indicated by the red colored screens on the computers. Over here you're going to have different data packets, indicated by their various colors, and they are going to be entering the red network's router from the internet. The router is only going to accept the red data packets because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network. This is a very simplified illustration of how a router works, but I think you'll get the idea. The purpose of a firewall is for security. It is essentially the doorway to a network. Its primary function is to control communication coming into and out of the network. As data is being sent into and out of the network, the firewall examines the data packets, and based on the rules that the administrator has configured, it determines what can enter and leave a network. Most firewalls are hardware, but a firewall can also be software. A modem is a device that allows a computer to transmit data over normal telephone lines. The data coming in from a telephone lines is analog. However, the data in a computer is all digital. So when the analog data comes in from the telephone lines, the modem's job is to convert it to a digital form so the computer can understand it. So that's basically what a modem does. It converts analog data to digital data. The maximum speed of most modems today is 56 kbps. A wireless access point is basically a hub that is used by wireless devices. It connects to a wired network and relays data between the wired network and the wireless device for communication purposes. In this illustration, you see a wireless access point wired to a network so the wireless laptop can communicate with the network. A gateway can be defined as a device that joins two networks together. They interconnect networks with different or incompatible communication protocols. A gateway does not change the data. It only changes the format of the data. In simple terms, this illustration is showing how a gateway is transforming a simple signal into something totally different. The circular pattern can represent one network, and as it goes through the gateway, it transforms into a wave pattern, which represents a different network. This objective covers network tools, and if you're already a network administrator, then the most common tool that you have probably used is the wire crimper. This tool is used to make custom length cables. It crimps adapters such as the RJ45 to Cat5 cables. So after you have attached your RJ45 adapter to your cable, just place it into the crimper, give it a squeeze, and the cable is done. A punch-down tool is a tool that resembles a screwdriver, and this is simply used to connect or punch wires to a punch-down block. Another network tool is the media tester. So after making a custom length cable using your wire crimper, it's a good idea to test the cable to make sure it's wired correctly. So you would just connect both ends of the cable in the tester, and then the tool will check the cable for you. A multimeter is a device that is used to test electrical circuits. It's a popular tool that is used for many different trades. It can measure voltage, resistance, current, and continuity, just to name a few. And it comes in both analog and digital versions. The plastic shielding around a networking cable must be removed in order to crimp the connector. This is done by using a cable stripper. The cable is then inserted into the tool, and the outer plastic shielding is removed. One of the most basic input devices on a computer is the keyboard. A keyboard is a device that is used to input commands to the computer. It has keys that are made up of alphabets, numbers, and symbols that you can press with your fingers. The most basic function of a keyboard is to do things like word processing, write letters, emails, visit web pages, and so on. Keyboards come equipped with two different connector types. They will have a 6-pin DIN connector, which is the older one, or they will have the more modern USB connector. A lot of keyboards will have both, because they will come with a DIN to USB adapter, which you can use with any computer with either a DIN or USB connection. A mouse is another basic input device that is used on a computer. It's a pointing device that fits in the palm of your hand and replicates the movement of the mouse onto the computer screen. It's used for things like starting applications, file and folder management, and surfing the internet. A mouse will typically have 1 or 2 buttons. A Macintosh mouse will have 1 button, while a Windows mouse will have at least 2 buttons. An older mouse will have a physical trackball underneath to record the mouse movement. This is called a mechanical mouse. These are pretty much now obsolete and have been replaced by the newer style optical mouse. An optical mouse uses light-emitting diodes that detects the mouse movement. There is also a laser mouse, and a laser mouse uses a laser to detect mouse movement. A digital camera is a device that takes digital pictures and videos. Unlike a standard camera where the images are stored on film, a digital camera stores the images digitally on an internal hard drive or on the camera's SD card. Once the images are stored, they can be then downloaded to a computer by using a USB cable or by the SD card. And once they're on a computer, the images can be viewed or printed. A barcode reader is a device that is used for reading barcodes. It uses a light to scan barcodes and is typically used to detect point of sales and maintain inventory. It can connect to a computer through a serial port, USB port, or a wireless connection. Barcode readers come in several forms, but the most popular is the handheld trigger type. A touch screen is basically an LCD monitor with an input detection system. It's a grid that senses the touch by a finger. It works the same way as using a mouse, but without the mouse itself, because you are using your finger instead. The touch screen receives the touch in the same way as if you were clicking a mouse button. Typically, one click on a mouse button equals 1 tap by a finger, and 2 clicks on the mouse equals 2 taps by your finger. Touchscreens are commonly used on all-in-one computers and tablets such as the iPad, and they are also used on certain cell phones with touchscreen technology. A webcam is a device that is used for capturing video and images. Webcams are mainly used for video conferencing and video calling over the internet. So two people anywhere in the world can visually communicate with each other if they both have a webcam and an internet connection. And most webcams have a built-in microphone to capture audio. Webcams are often used with messaging applications such as Skype for making visual calls. Two of the biggest manufacturers of webcams are Logitech and Microsoft. And a webcam connects to a computer using a USB cable. A media reader card gives the computer the ability to read memory cards from devices such as cameras. It's a small device that usually has a USB cable attached at one end that connects to a computer. The body of the reader has slots to accommodate various sizes of memory cards. For example, micro SD and mini SD cards. And once installed, the data from the memory cards can be read and transferred to the computer. A docking station is used for laptop computers. It's a device that is used for basically turning your laptop into virtually a desktop computer. We all know that laptops are generally smaller than desktops. For example, on the laptop, the monitor and keyboard are generally small. So if you wanted to use your laptop at your desk and you wanted to use a bigger monitor and keyboard, you can simply set the laptop in the docking station and it will automatically connect to them and use them depending on what is already plugged into the docking station, whether it's a monitor, keyboard, mouse, printer, and so on. It eliminates the hassle of connecting all of these individually. You just simply attach them and start using them instantly. There's one thing to remember with docking stations, is that they are specific to the manufacturer. So there is no such thing as a one-size-fits-all docking station. So you need to get the specific one for your laptop. A KVM switch allows you to control multiple computers from a single monitor, keyboard, and mouse. A KVM is typically a box with ports for a video, mouse, and keyboard. Each computer has their own individual cable connections to the KVM. Each KVM has buttons that you can press, so you can switch to a different computer you want to control. KVMs also come in different sizes, depending on how many computers the KVM can handle. A low-end KVM switch will have the ability to control 2 computers, while a higher-end KVM can control 8 computers. KVMs are very handy when you want to control multiple computers without the need for a dedicated monitor, keyboard, and mouse for each one. This not only saves money, but it also saves space. A computer monitor is the primary output component of a computer. It connects to the computer's video adapter through a monitor cable and displays images on the screen. A computer monitor may have a VGA, DVI, or HDMI video port. There are 2 main types of monitors. One type is called CRT. CRT stands for cathode ray tube, which was the technology first used in TV sets. These monitors are bulky and heavy and take up a lot of desk space, and are pretty much non-existent in the marketplace today. An image is produced on a CRT by using 3 color electron guns. These colors are red, blue, and green, which can be combined to produce any color on the color spectrum. And these guns shoot beams of electrons on the screen and create an image that we see. These beams repeatedly sweep across the face of the monitor many times per second. So it is constantly redrawing the image that we see on the screen. And this redrawing of the image is known as the refresh rate. And the refresh rate is measured in hertz. So for example, if the refresh rate is set to 60 hertz, then this means that the beams sweep across the entire face of the monitor, redrawing the image at a rate of 60 times per second. Now, to the naked eye, most people cannot detect this because it does it so fast. But a lot of times, some people complain of discomfort in their eyes because they are noticing the constant refreshing of the image. But this problem is usually solved by increasing the refresh rate, which makes the refreshing of the image less noticeable, which reduces the amount of eye discomfort. Inside CRT monitors is a metal plate called a shadow mask. And this metal plate can pick up outside external magnetic fields, which can cause discoloration on the screen. And because of this, CRT monitors need to be degaussed. Degaussing is the process of getting rid of the unwanted magnetic fields. Most CRTs do an automatic degauss when the monitor is turned on, or the monitor may have a button that you can manually press to do a degauss. Today, most computer monitors are LCD, which stands for liquid crystal display. LCD monitors produce an image on a flat surface by using liquid crystals. Light shines through these crystals to produce an image on the screen, and it uses filters to produce different colors. LCDs were first used in laptop computers and have now made their way to the desktop market and have completely replaced CRT monitors. They are lighter, thinner, use less power, and take up less space than CRTs. LCDs are also known as flat panel displays. Modern LCDs use a technology called TFT, which stands for Thin Film Transistor. And as the name implies, this technology uses a thin film transistor to create a high-quality image when compared to a standard LCD, because each single pixel on the screen has its own transistor. And all LCDs sold today have TFT technology. Resolution is defined as a number of pixels that are used to display an image on the screen. For example, if a monitor is set to a resolution of 1280 by 720, then this means that there are 1280 horizontal pixels by 720 vertical pixels, which means that there are 921,600 total pixels that are being used. The higher the resolution, the higher the number of pixels will be used, which means a clearer and sharper image. Depending upon the hardware and software being used, resolutions can be set anywhere from 640 by 480 up to 1920 by 1200 or more. LCDs produce their best quality image when they are set to their highest resolution, which is called their native resolution. Resolutions are also given different names for identity purposes. For example, XGA stands for Extended Graphics Array. This has a resolution of 1028 by 768. SXGA stands for Super Extended Graphics Array. This has a resolution of 1280 by 1024. SXGA Plus stands for Super Extended Graphics Array Plus. This has a resolution of 1400 by 1050. UXGA stands for Ultra Extended Graphics Array. This has a resolution of 1600 by 1200. And WUXGA stands for Widescreen Ultra Extended Graphics Array. And this has a resolution of 1920 by 1200. And lastly, the contrast ratio. The contrast ratio refers to the contrast between black and white. The higher the contrast, the better the display. BIOS stands for Basic Input Output System. The BIOS is software that is built into the motherboard that initializes the computer's peripherals as the computer is being booted. Some of these peripherals include the keyboard, mouse, video card, optical drives, and so on. And after it initializes the peripherals, it then searches for a boot device, like an optical drive or a hard drive, to boot software or to boot an operating system. The BIOS software is stored on the BIOS chip on the motherboard. The BIOS chip is non-volatile, which means that the software and settings are retained even after the power is turned off. On modern computers, the BIOS is stored on flash memory chips, which makes the BIOS capable of being updated using a special program. Some popular vendors of BIOS software are American Megatrends and Phoenix Technologies. After a computer is turned off, and if the power cable is unplugged, the computer needs to maintain certain settings, such as the date and time and hardware settings. And these settings are stored on the motherboard in a special chip called a CMOS chip. CMOS stands for Complementary Metallic Oxide Semiconductor. And in order for the CMOS chip to maintain these settings, it needs a battery. This battery is called the CMOS battery. The CMOS battery is a small button cell battery which can be seen on the surface of the motherboard and is usually located on the bottom right-hand corner. The CMOS battery is basically the same type that is typically used in wristwatches. When you turn on a computer, the computer does what's called a power-on self-test, or POST, that is run by the BIOS. It tests the computer to make sure all the requirements are met and the hardware is working correctly before continuing. And after POST is passed, the BIOS searches for something to boot from, such as an operating system, which is typically loaded on the hard drive. But the computer doesn't necessarily have to boot to an operating system. It can also boot from other things, such as a CD or DVD disc, floppy disk, or USB flash drive, just as long as those things have the necessary boot files on them. And how the BIOS determines which device to boot from depends on the boot order in the CMOS settings. And in the CMOS settings, you can make changes in the priority boot sequence. So for example, if the CD or DVD drive is set as the first boot device, then the BIOS would check that first and look for software to boot from. And if it doesn't find anything, it will move on to the second device on the list and check that next. And it will continue down the list until it finds something to boot from. But you can change the boot priority in CMOS in any order you choose. And once you make the change, you just save the settings, and the next time you reboot the computer, the settings will take effect. Typically located at the bottom right-hand corner of the motherboard, you'll find what's called the front panel connector. And this is where you would plug in wires that connect to items that are in the front bezel of the computer case. So for example, there is the power button connector, and this turns the computer on or off. There's also the power LED, which indicates when the computer is on or off or in standby mode. There is also the hard drive LED, which indicates when there is hard drive activity. And there is also the reset switch, which restarts the computer by doing a hard boot. And there's also a speaker connector, which is used to plug in the internal speaker of the computer. Now oftentimes the front panel connector will be color-coded, as you see here, and this is to help identify where the wires connect to, which makes knowing where to connect the wires a lot easier. The operating system is a software program that provides an environment to execute commands. It gives you a user interface with a computer so you can use hardware and run programs. It basically acts as a middleman between programs and computer hardware. You cannot run a program without an operating system. Now, of all operating systems, Microsoft Windows is the most popular and widely used operating system. According to estimates, approximately 80% of the personal computer market is using Windows as the operating system. Windows was first released in 1985 and has since released several different versions of Windows in the years following. But for the exam, we're going to start off by talking about Windows 2000. Windows 2000 was released in the year 2000. It was the successor of Windows NT 4.0, which was released 4 years prior. Windows 2000 had 4 different versions. There was Professional, Server, Advanced Server, and Data Center Server. Windows 2000 was the first operating system to use the recovery console, which means that you can recover from problems if Windows does not boot by providing commands using a command line interface. The recovery console is accessed by booting from the Windows 2000 CD and selecting Recovery Console. The minimum requirements for Windows 2000 Professional are a 133 MHz Pentium processor, 32 megabytes of RAM, and 650 megabytes of hard drive space. One year after Windows 2000 was released, Microsoft released Windows XP in 2001. And even though it was released in 2001, Windows XP is still widely used today, especially in the home computer market. And like Windows 2000, Windows XP also came in 4 different versions. There was the Home Edition, Professional Edition, Media Center Edition, and a 64-bit version. Windows XP was an upgrade to Windows 2000, with improvements in networking and multimedia technologies. It was the first OS to introduce Windows Remote Assistance, which allows you to remotely control another computer over a network or the Internet. The minimum requirements for Windows XP Home and Professional are a 233 MHz processor, 64 megabytes of RAM, and 1.5 gigabytes of hard drive space. In Windows XP, there is a feature called the Automated System Recovery, and this is used to restore your computer's files and services in case a disaster happens. The ASR is a 2-step process. The first step is the backup, and the second step is the restore. The backup is created using the backup utility located under System Tools in the Start menu. From here, you can back up the system state, system services and data, and back them up on another volume other than a C drive. And this is because the C drive will be reformatted and all the data will be lost. So you need to back them up on another volume. And once the backup is done, you'll be asked to insert a floppy disk to complete the backup. And to do the restore, you need to restart the computer and boot with the Windows XP CD. And in the Windows setup screen, you need to press the F2 key as soon as you see press F2 to run the ASR on the bottom of the screen. And from here, just follow the instructions on the screen and the restore process would take place. And you can fully restore your computer with the backup you created. It's also important to note that everything on the drive since the ASR backup was created will be lost. So it's important to create a backup as often as possible in case of a disaster. In January of 2007, Microsoft released the successor to Windows XP, and it was called Windows Vista, which was codenamed Longhorn by Microsoft. Vista introduced a new graphical interface called Arrow, which gave Vista a more advanced and cleaner look, such as window transparency and animations. It also introduced the sidebar, which is a transparent panel that is placed on the side of a desktop. And in the sidebar you can place a variety of Microsoft gadgets. Some of these gadgets include an analog clock, calendar, CPU meter, and so on. And Vista also introduced a feature called the UAC, which stands for User Account Control. The UAC is a security feature that enables users to perform common tasks with limiting their privileges by default. So for example, if you are logged in as an administrator and you wanted to perform an administrative task such as installing a program, the UAC window will pop up on your screen and prompt you with a choice of yes or no to confirm if you are sure you wanted to install the program. And if you were logged in as a standard user, the UAC would pop up and ask for a password instead. The UAC was intended to make the operating system more secure by granting users and applications the lowest level of permission before potentially making a disastrous change to the computer. Now, a lot of people have often criticized this feature because of the annoying pop-up window when performing basic tasks. But the UAC can be turned off in the control panel under User Accounts. Windows Vista has 4 different versions. There is Vista Home Basic, Home Premium, Business, and Ultimate Edition. The minimum requirements for Windows Vista are an 800 MHz processor, 512 megs of RAM, and 15 gigabytes of hard drive space. The latest operating system from Microsoft as of 2011 is Windows 7. Windows 7 was released in 2009, and it was designed to be more user-friendly, more compatible, and have a better performance than Windows Vista. It featured a new transparent taskbar with larger icons to accommodate touch screen input. It also had a feature called Arrow Shake, which allows you to minimize all other windows by shaking the one you want to focus on. It also features a desktop slideshow that automatically changes the desktop background in a user-defined amount of time. Windows 7 also came in 4 different versions. Windows 7 Starter Edition, which contains the fewest features. This was generally installed on cheaper computers and notebooks, and is only available in 32-bit. There is also Windows 7 Home Premium, Windows 7 Professional, and Windows 7 Ultimate. The minimum requirements for Windows 7 32-bit are a 1 GHz processor, 1 GB of RAM, and 16 GB of hard drive space. The requirements for the 64-bit versions are a 1 GHz processor, 2 gigabytes of RAM, and 20 gigabytes of hard drive space. A great feature in Windows that you can use to solve problems is what's called Safe Mode. Safe Mode is a mode that you can boot the computer into to solve problems. In Safe Mode, the operating system is booted with a minimal configuration of basic files and drivers. You will only be able to use the keyboard, mouse, and video in Safe Mode because it only loads those drivers. And the video on your screen will have a resolution of 600 by 800 because it only loads a basic VGA driver. And you will also see the words Safe Mode in all 4 corners of your screen. Once you're in Safe Mode, you can fix a problem that you might be experiencing, such as a bad driver, fix a user configuration, or restore files. To start the computer in Safe Mode, press and hold the F8 key as soon as you turn on the computer. Then you will see the Advanced Options menu, and from here you can select Safe Mode. There is also the option if you wanted to be able to network or go online and use the internet in Safe Mode. Then you can choose the option that says Safe Mode with Networking, which enables the network card. If you are having trouble starting the operating system, there is another option in the Advanced Options menu that is called the Last Known Good Configuration. And this option uses the most recent operating system settings that worked correctly. Every single time you shut down your computer and Windows shuts down correctly, Windows will save those settings in the registry. So in the future, if you are ever having a problem where the computer won't start because of a recent change to the operating system, like a bad driver or setting, you can select the last known good configuration to turn back the clock and start the computer to the state where it last worked. It's also important to know that using this option will not affect your personal files. It only affects the operating system settings, so you don't have to worry about losing any of your personal data. Another option that you can use if you can't start the operating system is by using the Emergency Repair Disk. The Emergency Repair Disk, or ERD, is created beforehand with the operating system. Oftentimes, when you get a new computer, you will get a message that prompts you to create the ERD in case something happens. When the ERD is created, it will contain certain information about your operating system settings and can be used to repair the operating system if it fails to start. The ERD is only used to make basic repairs to start the operating system, so it doesn't back up any personal files. If you ever worked on a computer with a Microsoft Windows operating system, then you may have encountered a situation where all of a sudden you see error messages in white with a solid blue background. And this is known as the blue screen of death. Blue screen of death errors are the most dreaded of all errors because it totally disables your computer from any user input commands from your keyboard or mouse. And the only thing you can do is press the power button on your computer and turn it off and do a reboot. A blue screen of death indicates a system failure, and it can be caused for a lot of reasons, such as incompatible or corrupt drivers, viruses, incompatible software, bad hardware such as RAM, hard drives, and PC cards, a corrupted operating system, or even overheating. When the blue screen of death error is displayed, it shows you information to help you diagnose what is causing it so you can fix the problem. So for example, on top of the error, you'll find an error description shown in uppercase letters. Then in the middle, you'll find some general troubleshooting steps. Then towards the bottom, you'll find some technical information which shows you a hexadecimal code, and you can use this code in the Microsoft Knowledge Base website for more specific details on what is causing the error so you can fix the problem. Sometimes when you're using the computer may totally freeze on you. The computer remains on, but you can't move the mouse cursor, and the keyboard is rendered useless. And this is known as system lockup. System lockups can happen for several different reasons. The main reason is that the computer has too many processes running and is running low on memory. And if this happens, sometimes the computer will recover and resume normally after a certain period of time. Or if it doesn't, you may have to reboot the computer. So to avoid this problem in the future, try to limit the amount of running unnecessary applications at one time and only use what you need. When installing a new application on a computer, the first thing you should do is to make sure it's compatible with your computer's operating system, because if it's not compatible, it will not work. That's why it's important, before you even purchase an application, is to check the label under System Requirements to make sure your computer meets them. Because if you buy a program that requires you to have Windows Vista or a later version of an operating system, and you are still using Windows XP, it will not work and you may have wasted your money. Another thing to check is the bit version. Some programs may only work on a 32-bit operating system and not a 64-bit operating system. Another thing to look for is when you're going to install an application, it is highly recommended that you close all other applications prior to the installation. By doing this, you can avoid any potential problems that could happen, such as program conflicts during the installation process. And some applications recommend that you also temporarily disable your firewall or your antivirus during the install. Windows Explorer shows the hierarchical structure of files, folders, and drives that is on your computer. You can use it to do a search, copy, move, and rename files and folders. And using Windows 7 here as an example, you can also access the personal library folders, such as a Documents folder, which is used as a default location for your personal documents. And there's also the Music, Pictures, and Video folders, which are the default locations for storing those types of files. Windows Explorer was first used in Windows 95 and has been in every Windows operating system since. To start Windows Explorer, just right-click the Start button and select Explore or Open Windows Explorer depending upon your operating system. You can create a new folder in Windows by right-clicking the mouse in a blank area and choose New Folder. The new folder will be created with the default name of New Folder, which you can rename to anything you want. And once the folder is created, you can start to fill it with the files you want, such as documents, pictures, videos, music, and so on. Every file has what's called a file extension. A file extension has at least 3 characters at the end of the file name, and there is a dot that separates the file name and the file extension. The file extension is used so that the operating system can tell what kind of file it is, so it can open the file with the correct application. For example, if the file is a simple text document, the file will have the extension of .txt. If the file is an image, it may have the extension of .jpg, .bmp, or .jpeg, just to name a few. Or if it is a music file, it may have the extension of .mp3. The file extension is not visible by default. It's hidden. And the reason why it's hidden is to prevent users from accidentally renaming, erasing, or modifying the file extension. which would result in rendering the file useless because the operating system would no longer be able to tell what kind of file it is. In order to see the file extension, you have to enable it in the folder options in the control panel. And once you select it and press OK, the file extension is now visible. msconfig is a run-line utility, and it stands for Microsoft System Configuration Utility. And this is a tool that is built into Microsoft operating systems. It is used to troubleshoot Windows startup processes. With msconfig, you can choose which programs and services will run when Windows starts. It can also edit some Windows configuration files, such as the boot INI, which allows the user to choose which operating system to boot from at startup if the computer has more than one operating system installed. But of these options, the most popular is choosing which programs run at startup. One of the main complaints with Windows users is that their computer runs slow. And one of the main causes of this is that Windows is running a lot of unnecessary programs in the background as the computer starts. So to solve this problem, we select the Startup tab, and we can go through the list of programs and deselect any programs that don't need to be running at startup. And the overwhelming majority of these programs that we see can be deselected and do not need to be running. Then when you're done, you press OK, the computer will ask you to reboot, and you'll find a big difference in the performance of the computer. msconfig was first released in Windows 98 and has been in every Windows operating system since, with the exception of Windows 2000. To access msconfig varies slightly depending on which operating system you are using, but as a general example, just click Start and in the Run dialog box, type msconfig and press Enter on the keyboard. Prior to installing a Windows operating system, there are a few things you need to do first before you install it. The first thing to do is to make sure that your computer hardware meets the necessary minimum requirements of the operating system that you're going to install. You should also consider the peripherals such as your printer, scanner, etc. are also going to be compatible. And if you're not sure if your peripherals are compatible, you can consult the Microsoft Hardware Compatibility List on the Microsoft website, and it will tell you if it's compatible or not. So using Windows 7 as an example here, the next thing you need to do is to decide whether you're going to do a clean install or a repair install. A repair install repairs the existing operating system. A repair install only affects the operating system. It does not affect your personal files, folders, and programs. A repair install replaces the operating system files and puts them back to their original state. So if you don't want any of your files and programs affected, the best option is to use the repair install. A clean install, however, will erase everything on the hard drive. So whether the hard drive has existing data on it or not, the partition that contains the operating system will be wiped clean. So if you wanted to do a clean install, and you have confirmed your hardware requirements, the next step is to put the Windows operating system disk in the optical drive and boot the computer from it, and follow the instructions on the screen. All Windows operating system disks, starting from Windows NT and later, are bootable, but older operating systems like Windows 98 and 95 are not. For those, you need to boot from the Windows floppy disk. And depending on what kind of hardware your computer has, the installation takes about 20 to 30 minutes. In addition to using the Windows disk to install the operating system, there is also a way to install over a network. A network installation is useful when you are installing Windows on multiple computers simultaneously. So this is basically done by first placing the necessary operating system installation files on a network file server inside a shared folder. Then you need to boot the client computers with a floppy disk or flash drive that has the necessary network card and client software on it. Then when prompted, you need the client computers to access the shared folder on the network file server. Then the installation will start. Once again, this is a very convenient way if you are installing the operating system on multiple computers at the same time. Another method to installing the operating system is by using the factory recovery partition. The recovery partition is a section on your hard drive that has a backup copy of the operating system, drivers, and software that originally came with a computer from the manufacturer. It allows you to return to the computer's original condition to when you first purchased the computer. To initiate the recovery process by accessing the recovery partition varies slightly depending on the manufacturer and the operating system. So typically, as soon as you turn on your computer during the boot process, you may see a message on your screen prompting you to press a certain key on your keyboard, like F10 or F11, to start the recovery process. Or if you're using Windows Vista or Windows 7, you may have to boot into the Advanced Boot Options menu by pressing the F8 key and then select Repair Your Computer. Like I said, these are just examples. So if you're not sure how to access the recovery partition for your particular computer, you can always consult with the manufacturer user manual to find out. Another way to install Windows is by using the recovery disk. Like the recovery partition, the recovery disk is a disk that also contains a backup copy of the operating system, drivers, and software that originally came with the computer from the manufacturer. It also allows you to return the computer's original condition when you first purchased the computer. You typically use the recovery disk when your hard drive has crashed, which basically means that your operating system and the recovery partition are no longer accessible and you have to install a new hard drive. And you would use the recovery disk to install the operating system and software on the new hard drive. Storage is another very important part of fault tolerance. If something were to happen to a company's data, such as a disk failure that results in data loss, then that could have a serious impact on how the company performs. That's why we need to make sure that if a disk does fail, that no data loss will occur. So one of the best ways to prevent data loss is RAID. RAID stands for Redundant Array of Independent Disks. In a RAID setup, the data is copied on multiple disks, so that in the event of a disk failure, no data will be lost. Now there are three common forms of RAID. There is RAID 0, RAID 1, and RAID 5. Now RAID 0 is not fault tolerant. In fact, RAID 0 shouldn't even be called RAID, because not only does it not provide fault tolerance, it actually increases the chance for data loss. Because in a RAID 0, the data is not duplicated, but it's actually spread or striped across two separate disks. So if just one of these disks fail, then all the data would be lost. So the only reason why you would want to use RAID 0 is for speed, because when you have two disk controllers working instead of one, accessing data is much faster. Now RAID 1 is fault tolerant. In a RAID 1 setup, the data is copied on more than one disk. So disk 2 will have the exact same copy of the data as disk 1. So in the event of a single disk failure, no data loss would happen because the other disk has a duplicate copy. There are also two different setups in RAID 1, mirroring and duplexing. Mirroring is when all the disks use the same controller, but duplexing is when each disk has their own controller. So duplexing is more fault tolerant of the two setups because it will still continue to function if a controller goes down. And finally, we have RAID 5. In order to use RAID 5, you need to have 3 or more disks. RAID 5 is probably the most common setup that is used because it's fast and it can store a large amount of data. In a RAID 5 setup, data is not duplicated, but it's striped or spread across multiple disks. And in addition to the data, there is another very important piece of information that is being evenly spread across all the disks. This information is called parity, and parity is used to rebuild the data in the event of a disk failure. But there is a downside to RAID 5, because since the equivalent of an entire disk is used to store parity, it reduces the collective amount of data that can be stored in this array. So for example, if all 4 of these disks were 100 gigabytes each, that totals 400 gigabytes. But in a RAID 5 setup, the total amount that could be used for data storage would be 300 gigabytes, because one entire disk would be used to store parity. Now we have to talk about RAID 10. And RAID 10 is basically what the name says. It's combining RAID 1 and RAID 0 together. And you need to use a minimum of 4 disks. So in a RAID 10 setup, a set of 2 disks are mirrored using a RAID 1 setup. Then both sets of the 2 disks are striped using RAID 0. So a RAID 10 setup benefits from the fault tolerance of RAID 1 and the speed of RAID 0. But the downside in a RAID 10 is that you can only use 50% of the capacity for your storage. So if you're using 4 disks in a RAID 10 setup, you can only use 2 of them for actual storage. When working on a computer, it's important to not do any damage to the computer components that could be caused by ESD, which stands for electrostatic discharge. And ESD happens when 2 objects of the opposite charge, such as your hand and a computer part, come in contact with each other. And when this happens, a sudden charge of electricity flows through the 2 objects. And this sudden charge of electricity can damage computer components. So to prevent this from happening, it's important to wear an ESD wrist strap. By wearing an ESD wrist strap, it can stop the buildup of static electricity in your body by safely grounding you. One end of the ESD strap fits around your wrist, and the other end is grounded. The grounded end can be either attached to the ground pin in a power outlet or clipped onto the metal case of the computer. Another thing you can do to protect against ESD is by using an ESD mat. An ESD mat is typically placed on a desk where assembly takes place, and the mat removes any electrical charge from the components that are placed on it. And just like an ESD wrist strap, an ESD mat is also connected to a ground. When dealing with our environment, it's important to understand what is the proper way to dispose certain pieces of equipment so that it doesn't affect the environment in a negative way. And computer-related equipment is no exception. For example, computers contain lead and harmful chemicals such as mercury that is harmful to the environment. And for this reason, they must be disposed of in a proper way. And if you're not sure how to dispose it, there is a data sheet you can find called the MSDS, which stands for Material Data Safety Sheet. and this will tell you the proper way to dispose that particular piece of equipment. The MSDS will typically be offered by the manufacturer, or you can download a copy of it from the EPA. As a computer technician, it's always important to put safety as a priority when doing any kind of repair work. And if you put certain safety rules into practice, you'll save yourself a lot of time, money, and potential physical harm. So for example, always be sure to turn off the power and unplug the power cable before doing any hardware repair work. This should be your first step before doing anything. This will protect you from being shocked and prevent damage to the computer. Another precaution you can take is to remove any hand jewelry that you might be wearing, such as rings, bracelets, or wristwatches, because these can potentially conduct electricity. Another tip is to always take note where a fire extinguisher is located and how to use it properly in case a fire happens. And in the computer field, a Class C fire extinguisher is what you'll need because a Class C is made for electrical fires. It uses a dry chemical powder to extinguish the flame. Another safety tip is cable management. Maintaining a safe work environment is a major part of any job, and tripping hazards is a vital part of it. So if you have cables running across walkways, you could be in a high risk for a tripping accident. So the quickest way to fix this is to simply relocate any cables that go across any walkway and move them somewhere else. Or if by some reason this can't be done, then you can always use something like a cable manager cover, which neatly organizes the cables in a way where you can't be tripped by them in high traffic walking areas. And another tip is proper lifting. So if you have to lift a heavy object, it's important that you lift the object properly to avoid any injury. You never use your back to lift a heavy object. You always use your legs. So start out with your feet shoulder width apart, squat down, maintain good posture by keeping your back straight at all times, and slowly lift by straightening out your legs. And finally, there's the appropriate use of communication and professionalism in the workplace. Now obviously, if you're a computer technician, you need to provide good and professional service to your customers. So the first tip is to always use proper language when talking to a customer. Try to avoid jargon, slang, and especially bad words. And don't talk down to the customer. Listen to what they're saying without interruption. Be sensitive to their needs and be understanding. This not only makes the customer feel better about your service, but it will assure you that they will return to you in the future. Another thing is to be on time if you have an appointment. And if you're going to be late, be sure to call the customer and let them know that you're going to be late, but assure them that you'll be there. You also need to avoid distractions when communicating with a customer. Things like turning off your phone if you have to, telling the other coworkers not to interrupt you when you're with a customer, turning off things like a radio or TV. So basically what you want to do is to try to keep your focus on the customer and their needs. And when you're dealing with certain customers, at some point you're going to come across a customer that is difficult to deal with. The customer may be frustrated and going through a difficult time, and they may decide to vent their frustration out on you. And at this point it is wise that you do not get defensive and to always remain calm. Don't minimize the customer's problems or be judgmental, but instead listen to them and be sensitive to their needs. Ask them open-ended questions to narrow the scope of the problem. Then it's a good idea to restate their problem back to them to verify that you understand their issue. You also need to set and meet expectations with the customer. Tell the customer when the problem is going to be fixed, and be sure to meet that timeline. And if you can't, be sure to contact the customer and tell them. And you should also provide the customer with the proper documentation about the repair you did. Give them a detailed list and breakdown of the work that is done, including the price of the parts and services. And at a later date, it's also a good idea to follow up with the customer. Ask them if they are satisfied with the work that was done. And finally, be sure to appropriately deal with the customer's confidential materials. With a lot of computer repairs, a lot of times you may need to back up the customer's data before you do work on their computer. So as you back up their data, it's important that their data does not end up in the wrong hands where someone has access to their personal files. So it's a good practice to keep their data in a safe place while their computer is being worked on. And once the work is done, and their data is restored to their computer, be sure to erase the backup data from the device that you used as a backup.